Hello scholars and welcome to chemistry class. Today we're going to be looking at empirical formula. We're going to be looking at how to calculate the empirical formula of a compound. Okay, so before we go into the calculation proper, I would like to explain what empirical formula is, okay? Now, empirical formula, put simple, can be seen as the simplest ratio of the number of different atoms present in a molecule of a compound, alright? So now, this is an example of what we can actually work out to get the empirical formula. Now, this question says a compound was formed by analysis to contain 65.45% carbon, 9.09% hydrogen, and 25.45% of nitrogen. Now, the question here says calculate its empirical formula. Okay, now the first thing you need to understand when you've been faced with a question like this, you have to then identify the relative atomic mass of each element in this compound, right? Okay, so now this is the compound. Now, a compound, as we know, elements make up a compound. Now, you also need to identify the various elements that make up the compound. Now, we have three elements. We have carbon, we have hydrogen, and we have nitrogen, okay? Now, they all have a percentage, and we now have our relative atomic number. Okay, now, we have carbon. Now, carbon contains 65.45, right? And hydrogen contains 9.09, while nitrogen contains 25.45. Alright, now these are their relative atomic masses. Now, the relative atomic mass of carbon, we have to be 12. Relative atomic mass of hydrogen, we have to be 1. And relative atomic mass of nitrogen, we have to be 14. Okay, now, once you have done this, you have solved half the question. Okay, now the next step, we bring this down, 65.45. Now, we also bring for hydrogen, which is 9.09. And then the last one, we bring the value of nitrogen, which is 25.45. Now, after doing this, the next step is to divide all this by the elements' relative atomic masses. Okay? Now, the relative atomic mass of carbon is 12. So we say 65.45 divided by 12. Relative atomic mass of hydrogen is 1. 9.09 divided by 1. And relative atomic mass of nitrogen is 14. So we have 25.45 divided by 14. Now, after arranging it like this, the next step would be to divide all of this. Now, after dividing it, you can then go further.